Hello, and welcome to another GeoGebra video, another GeoGebra making a tessellation video. So the last video I posted was about making a tessellation in GeoGebra's online calculator. But when I work for myself, I usually work on the downloaded GeoGebra Classic 5 version. So I wanted to do an example of what that looks like. And it also goes with a new post I've been trying to write for Henri Picciotto's math ed blog. Okay, so I was thinking about tiles and motions. I was experimenting with squares for the post I was writing and thinking about glide reflection and combined with midpoint rotations. I thought it's kind of too bad that you need midpoint rotations on both sides. What would a glide reflection look like with a triangle? And I realized that if it was an isosceles triangle, with the translation perpendicular to the axis of symmetry, I think that would work for a tessellation. So I'm going to go ahead and give it a try here and see what happens. So I'm just doing the points. To make an isosceles triangle, there's lots of different ways to do it. I could make something with equal angles. I could make kind of the apex and one of the base vertices and then reflect it across a line. But in this case, I want to start with the base, and then if I put point on the line, then this will give me an isosceles triangle. And then I'm going to want the idea should be that if it slides in this direction and flips across the line perpendicular to that, this side, the AC, will match up with the BC. All right. This will get a little bit into the details of some of the things I do. So for the tessellation, all we really have to do is put some points here to apply the modification to make an Escherized tessellation. But then when we move our original points, those points don't move, and you can get some really wonky things. So sometimes what I do is put these points in some kind of shape defined by the points that I've got. So let me think about one thing I've been doing lately is making kind of a rectangle around these points and then putting the points in that rectangle. Point in, instead of putting a point on the boundary, gives you points on the interior that you can move up into the boundary. And so I want these to be roughly in the rectangle. I'll say B plus V up here, going to C plus V, going to C minus V, going to B minus V. All right. And then so I can put D anywhere around here. And if I make big changes, D kind of moves proportionally to that. So it's especially nice to be able to kind of change the controlling points of your shape and have the points doing the edge alteration move along with them. All right, and instead of typing that all out a bunch of times, I'm just going to arrow up and So for that glide reflection, I'm going to kind of need to know the midpoint of this altitude. So I'm going to intersect the segment from A to B with that line. Usually the first line is named F. Get the perpendicular bisector, which I think I was already on. And I'll reflect these points of these lines and then translate them. So how far do they have to translate? Right, so imagine if I have this side reflected, it would be across that line, it would be here. So I want to move that side up to match here. So I think the vector I want for the translation is going to be just kind of halfway up the triangle. If you can't visualize, maybe I should do that and just kind of show you, right? So we're imagining what motion takes this segment onto that one. And I'm saying I want to reflect it. That's segment H. And even though it says point here, I can fill in a line. So I'm going to put line G. And it's showing me what it would be. But then I want to translate it. And that goes translate your object, then by a vector. And my new vector is W. And see, that fits in exactly that side that I wanted. We won't need those actual sides there. What I want to do that with is the points. So instead of H, we're going to do that to these points D, E, F, G. And we can see kind of which ones are the corresponding ones. And that is also going to be handy when it's time to make the polygon, the tile, the final tile. Okay, so I was distracted because I was thinking about kind of what space do I want these in. So this third side has to match itself, and the only tessellation motion where a side matches itself is midpoint rotation. We could reflect this triangle over to here, but then we can't make kind of any alterations to that side. This is a pretty compact space, and then we get kind of double, so I'm going to put 2 points in here. I wonder if I did it in kind of a circle, how that would work out. So I'm going to do the point in command again, and I'll do a circle from H, and it says radius number, but you can fill it in with any information that makes a circle, so I'm going to say through point A. So I get a point down here. I hit escape, that gives you the select tool again. And I want one more of those. Okay, and I've got to rotate those around H. So it turns out GeoGebra they don't have a glide reflection tool, which I would love to see at some point. And they do have reflect about a point, which is actually a 180-degree rotation around a point. I'm not sure why they have that as a separate motion, but I love almost everything about this tool, so I'm not going to question them too much. There must be somebody who likes that there as an option. One nice difference between the desktop is that when you fill in an angle on the desktop, that's the what comes up the next time. All right. So I'm going to go ahead and use these corner points. Otherwise, there's really a lot to think about. Escher a lot of times figured out kind of what to do if he cut off a corner, where that corner would have to go. But for the purposes of this demonstration, I'm going to go ahead and use A, B, and C from the original triangle as a part of the polygon. So, time to make the tile. Go ahead and start with A. The Polygon Tool, you just select every point you want in there. If you select a point by mistake, you can click it again and it releases it. Spend a lot of time thinking about how to recover from mistakes. Okay, so we've got this tile, and we think that if it rotates around, it is going to fit midpoint rotation, and a glide reflection in this direction will make the tile fit above and below. All right, so what we need next is to hide a lot of these points. So it turns out when we go ahead and perform the motions to the tile, then we get images of all these points showing if the points are showing when we make the transformation. So a lot of times I like to kind of hide these points for when we're doing the operations. So I don't think I need these lines showing anymore. Get rid of this. That's a lot of the noise. Now I do want to remember kind of the points I was using. So point H, what did I do? I left a line. All right. And remember, point H is the point that I want to do the rotation around. And I had the command in here for the glide reflection. I'll be able to use that same command for the tile. And what is that polygon named? It's the first one I've made, so it's polygon 1. So if I hit poly 1, I didn't go up far enough. So instead of a single point, I want to do poly 1. Oh, and look at that, a perfect fit. So to go down, I want to do the same reflection, but the opposite. And from this point, if I want it to do more, right, so this you can see is just kind of a translation of if we skip a space. So I could do the same glide reflection to this tile, or I could just translate this one up twice the vector. Because if we reflect across the same line twice, that's the identity. So that's all we're left with are the double translation. So I'll translate our poly 1 2W. So that's nice up there. And then I can get another one by going minus 2W. Okay. All right. So pretty good off to that side. And now I want to do the rotations. So that was to rotate poly 1. 180 degrees is the angle for those midpoint rotations. On a Mac, Control-O gets you the little degree mark, and it would rotate right there, but I want to rotate around a specific point. That gets me the one I want. Okay. Now, if I reflect this across the center line, it'll put the tile over here somewhere, which is not what I want. I want to reflect it over kind of the line through the center of the object, which is probably why there's no glide reflection command, because that's really messy. So I want to think about translating this point, this line, to where it goes here. Or I could make another perpendicular bisector from H and the transformation of point A. So the vector should just be from the apex of the triangle to the that midpoint on the base. So I'll try that. So translate, that's line G, and the vector from want C to H. Looks like it's in the right spot. So if I go back to my glide reflection, I want to know, well, what's the name of this polygon? Polygon 1 prime sub 2. Sub is the underscore, and I don't want to go around G. I want to go around line G prime sub 3. So that is some funky naming, probably because we have so many segments here. Those other names have already been used. And I had minus W here, so it goes down. If I do plus W, it'll go up. And from here, I can fill in a couple more, right? This was poly 1 prime 2. I can, once I've got those two, I can just do it all by translations. Okay. And what about this other side here? What would be the way to get something over there? So we could think about kind of what motion would take this one to that one, and then this one should be kind of the same thing. So there's a reflection in there and a translation. It's probably going to be easier just to go ahead and rotate. So what I'm going to do is my point H, I want to know where that is over here. So I'm going to do the glide reflection to it. And if I put H in here, whoops, and that was across my original line G. And if I go down, it goes there. If I go up, it goes there. Okay, and this one was called poly 2. So I want to rotate poly 2 180 degrees around point U1. And then I need the glide reflection of that, which means I need this line on the other side. So I do a lot of shortcutting by kind of going back to finding command I did before. So I'm going to switch around the order of H and C so the vector goes in the other direction. All right, and this is poly 2 prime. So I want to reflect it across my new line here and then translate it down W. Okay, so our original triangle was here, and now we've got a ring of tiles completely around it, so that should help us kind of see that this is a tessellation and get a feel for what the tessellation looks like. I can look through the list for this U sub 1, or I could have just control-clicked, right-clicked on the tile to see what it looks like. All right, so sometimes I do colorings here to kind of for all the different positions that something winds up in. So this triangle, this triangle, this triangle, this triangle are all the same colors. So the same orientation. Is that right? Oh, no, 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 they're not. Right, because there was that flip. Right, so these are in the same orientation. All right. So for people to be able to play around with the tessellation, we want those control points back up, right? So A and B controlled. C was the apex of the triangle. And we can see that if we move these, we can kind of change scale. Because we put those control points in polygon that's defined by those points, that'll kind of move along with it. Some funky things because we kind of put in the circle. That feels like a pretty good range of motion. All right. One thing I like to do is for people to be able to kind of make a pretty picture, give an option to kind of hide those points. So I did the checkbox, which creates a Boolean variable. And then if you kind of click the points, it'll go ahead and put them in the list for what shows or doesn't show, depending on whether the checkbox is checked or not. And then I didn't give it a label because I'm trying to be kind of minimal. So I'll take that off. And then move it over to a corner here. Okay, so if I click this, escape, escape. If I click this, they all show up, they all go away. That's what I want. And then some kind of visual difference. And there, I've got a pretty nice little tessellation with glide reflection in this direction. It's a little reminiscent here of Escher's geese, right, which have this kind of flock flying this way and a flock flying that way. Although he then does some nice kind of decomposition, spreading them out as they go along. I've got to think someday about how to do more of those kinds of effects in GeoGebra. But that's the tutorial. If you have questions, if you have ideas for how I could have made this better or what you might like to see next, please go ahead and put them on the comments in the video or to Twitter to @mathombre. And that's it. Thanks very much if you made it through the whole thing. Ciao.